Anything besides oil and refrigerant is not supposed to be in the system.
Pipe size.
Other than pipe size, your dryer will have a capacity rating on it. It will say, this is suitable from this capacity to that capacity. How do we test for restriction without looking on this board? Who can tell me how someone would check restriction on a dryer, if you want to guess? Just guess. We know how restriction works. How would you check for it? That's good, yes, he's right. No, temperature, temperature difference, yes. Because if there's restriction, there will be a temperature difference. Here's some common mistakes. Installing the filter dryer the wrong way. Okay, so where there's an arrow, if you basically install it opposite where the arrow is flowing. Oversizing and undersizing dryers. Not understanding what you're doing. You just go there, you're just installing a dryer just because you want to install a dryer. It's easy to say, oh, there's acid in the system. But it's another thing to prove it. PVE. Okay, POE, PVE. But there's one bad thing about POE and PEE. What is that? Exactly. It's very hygroscopic. So when you hear the word hygroscopic, it means it absorbs moisture. Okay, so that is why it's very important to vacuum or evacuate our system on all the newer systems running off PVE and POE because of its property to absorb moisture, the oil. Okay, and then it's very hard to remove moisture from oil. Just make it clear, hygroscopic. So hygroscopic, it's got the ability to absorb moisture and extremely quickly. Purging. So this needs to be a standard rule. We are not supposed to braze at all if we do not nitrogen purge. What's the pros and cons? Without nitrogen purging, oxygen inside reacts with the hot copper.
Still isn't leaked that.
Then copper oxide is getting formed. This black scale forms inside your pipe work. And oxidization black scale will actually start blocking up your EEV strainers. So if we do have an EEV somewhere, we'll cut it open. You'll see there's like a small mesh strainer, like a metal mesh strainer. It will actually block it up completely. Also TXVs on refrigeration systems. It will contaminate your oil. Okay, we don't want that contamination. Contamination is bad. Small ball to float and then you know, okay, you're purging enough nitrogen through the system. Everyone seen it? Or you can just guess it. Okay, you can just make sure that it's barely flowing. So not too much, not too little, but it must flow, but at a very low flow rate. Okay, 1 to 3 psi is basically nothing. Okay, you want to put it against your cheek and you just want to barely feel it. That's enough. Okay, don't start blasting nitro through it and think that's gonna be good because you're gonna struggle to braze. Am I right? Who's trying and braze doing nitrogen purge? And this is why a lot of people give up on nitrogen purging. Is because they braze, but they flow too much nitrogen. That is why we stop nitrogen purging. Is because we can't braze. We can't braze while we nitrogen purge. But if we reduce our flow rate, just get the right amount of nitrogen flowing through, mate, you won't struggle. Okay, another big mistake people do, I need to touch on this, is do your brazing, let the nitrogen purge up to the point where your joints has cooled down. Pressure testing and leak testing. When doing pressure testing, we always pressure test slightly higher or at the highest point that system will operate. Okay, so on the head pressure side, or if it's a reverse cycle or a heat pump system, the higher that system will run. When we pressure test, don't blast nitrogen into your system very fast. Slowly increase your pressure. Okay, especially if you've done brazing. You don't want to go start cracking all your brazing points and stuff. Slowly increase the pressure up to the point where it smashes 450 to 600 psi. Okay, very important, especially the younger guys. Don't go and just and then 600 psi. Never do that. Okay, so don't preset your regulator to 600 psi and only just open your nitrogen bottle. Don't do that. It's a big no. So always start at 0 and then slowly increase the pressure in your regulator. Build it up to about 200. This is my recommendation. This is what you can do. Build up to 200 psi and then start checking for big leaks. Okay. After you see, okay, there's no big leaks, you increase it to 400 psi. Then you start checking again. Okay. And then from there on, you're going to 600 psi. If it's a small amount of nitrogen, so if it's a new install and it's just nitrogen inside our indoor unit and our pipes between the indoor and the outdoor, just slowly go up to 600 psi and then start doing your leak check. VRF systems, higher pressure. Okay, so with VRF systems, we're running at much higher pressure compared to normal DX units. So we're supposed to go even higher than 600 psi. Okay, but that's even if you go into the manufacturer and manual, and again, all this stuff is stuff you need to refer to the manufacturer. If the manufacturer is saying, as an example, MHI, if they say, pressure test our VRF systems to 600 psi, then go for that. Only pressure test MHI systems up to 600 psi, always. Okay. We'll do some pressure testing. One thing I want everyone, especially on people doing installs on VRFs, is either a pressure probe or a digital gauge. Okay, so you don't have to have a digital gauge, at least just get a pressure probe. Okay, and this will benefit you, and we will see why it will benefit you. It's also not a must, it's not mandatory. If it's a micro leak, if you are 100% sure there's a leak, okay, what are you going to do? You're going to just leave nitrogen in the system and return back. That's what I would recommend, because it's better than you trying to evacuate, you trying to charge the system up again, and then a year passes and then boom, there's a leak again. Leak detectors, who trusts it, who doesn't trust it? Why not? It's 2026, but you get different types of ones. So you get one like this, which is a diode one, but what is accurate is the infrared ones. Let's say this is refrigerant. See, as I'm getting closer, I'm sniffing out the leak, boom, it goes off. That's exactly how a refrigerant leak detector will work. Really start looking into leak detectors. Just add nitrogen to your system. Raise that pressure to 400, 500 psi, and then start going around with your electronic leak detector and start sniffing it out. You'll get it very quick. What is atmospheric pressure in microns? I'm trying to cover it here.
760,000.
Yes, 760,000 microns is atmospheric pressure. How much is atmospheric pressure in PSI? 14.7. In KPA? Very nice, yes, 101. Okay, so it's important to understand we're also living in pressure. That's why when we reduce that pressure, atmospheric pressure starts boiling, because we're reducing the boiling point for water. Okay. Vacuum pump. You connect your vacuum hose straight here directly to a core removal tool. Okay, and then from the core removal tool, that's connected to the system. Okay, removing your shredder core also removes restriction, so you'll vacuum faster. Okay, this is all stuff I recommend you do. If you haven't done it and you start doing it, you will see the difference. Guaranteed you will see the difference.
And if you open them back up again, and now you should be able to wiggle that in. Nice, so try go again. But just that first bit. Yep. Keep going, as far as it wants to go. That's it. Alright, and now you should be able to wiggle that in a bit easier. There you go. Now it's important when you do this, just do like go half, so like halfway. And then you want to stop there and then rotate it, just so you know you're getting a nice circle.
Nice.
Just make sure that wants to be nice and straight in line with that, without taking my fingers off. Keep going. That's it. Beautiful.